In this tutorial, I'll be showing you how to add or differentiate different types of bonds in your 3D molecule models for ClassVR, as well as some quick tricks to speed up the process. To start, I'll show you how you can create a glycylglycine molecule and highlight the peptide bond before I show you two ways in which you can demonstrate the hydrogen bonding between water molecules. Please note that this video is being recorded in October of 2020 on a Windows 10 PC. Let's start with creating the glycylglycine molecule by opening up Avogadro. As usual, we start by ensuring both the tool settings and display settings boxes are highlighted in blue and selected. Next, we just ensure that only the ball and stick and label checkboxes under the display types tab are checked, and then we can go ahead and begin to draw our glycylglycine molecule by selecting carbon and clicking and dragging to add our first pair of carbon atoms. Next, we can go ahead and select nitrogen as our element and replace any hydrogen atom we want with an amine group by simply clicking on it. Now, the reason why it fills in these extra two hydrogens is because we have the Adjust Hydrogens box checked over here. Next, we can go ahead and select oxygen, set our bond order to double. Now, to add the double bonded oxygen, what we need to do is, instead of just clicking on the hydrogen atom we want to replace, we need to click on it and drag towards the carbon atom, and that will actually have the double bond show up, like so. Next, let's add the single bonded oxygen atom by selecting single bond order, and then clicking on the other hydrogen atom to replace it. And that finalizes our glycine molecule, which we can then hit extensions and optimize geometry to make neater. And now to finish our glycylglycine molecule, which, as you'll know, consists of two sort of glycine molecules bonded together, we can either use the draw tool and right click on an atom to remove it, and as we did before, draw the rest of the molecule, repeating this process, which can be quite arduous, but for the case of glycylglycine, since it's only two amino acids, it's not too bad, like so. However, as you can imagine, this gets quite tedious if you have a much longer peptide. So the better solution in this case would be to just start with our glycine molecule and then copy and paste this by going up to the selection tool, which looks like the black cursor at the top, or you can press F11, and if you hover over it, it has this control scheme here, but all you really need to know is that it's left click to select and right click to deselect. So with this tool selected, what we're going to do is left click and drag to highlight the entire molecule, press Ctrl C to copy, right click anywhere in this black space to deselect this molecule, and if we press Ctrl V to paste, it will paste the new molecule exactly in the same spot as the old one, which is why you can see some overlap in the labels. Next, the software should have already selected the manipulation tool for us, which looks like a white glove, or you can select it by pressing F10. Just double check that that is selected, and then click on anywhere in this black space, and it's important it's the black space and not the molecule itself. Click and drag to move the duplicated glycine off to the side, and then release to place it down. Now, I'd recommend going back to the selection tool, or the black cursor, and just right clicking anywhere in this black space to deselect this duplicated molecule. Now we need to link it up, and we can do this by going back to the draw tool, which is the little pen, and as we did before, we right click to get rid of atoms we don't want, and now we can't actually get rid of these two hydrogens because we have our Adjust Hydrogens box checked. So let's go ahead and uncheck that. Now I'd recommend just selecting hydrogen, just so the software doesn't get confused. You can get rid of these two hydrogen atoms, and we can link the nitrogen and the carbon by simply clicking and dragging between them. And that's created a double bond because I forgot to set the bond order to single, so make sure you do that. So now that we have selected single, once again, just click and drag between the two, like so. And if we go ahead and go up to extensions at the top and click optimize geometry, we'll see that we have our glycylglycine molecule created. So now we can go ahead and export this by pressing File, Save, and by naming the file, I'm just going to call this glycylglycine. I'm going to save this to the desktop so that it's easy to access. Save it and close down Avogadro, and as you'll see, our file is now over here on the desktop. So the next step is to once again import this into Blender. We do this by first opening up Blender and then clicking anywhere to get rid of this pop-up. Once again, delete this cube, pressing delete after it's highlighted. Go up to File, press Import, press Protein Data Bank, and go and select your file. For me, mine is saved on the desktop. And now using the previous tutorial's preset creation, we can click this drop down and select the preset that we made previously. I called mine ClassVR, yours may be different. Just select it, and now this correctly configures all the settings, so we can just go ahead and press import. As you can see, we have our molecule, but once again, we need to make sure we get rid of those pesky duplicate atoms rather. So we press A to select the whole molecule, go up to Object in the top left, press Apply, make instances real, and then go up to Object again, press Show/Hide, press Show Hidden Objects, and that'll reveal our duplicate atoms. So what we do is we deselect the molecule by just left-clicking anywhere, and then we can click on the atoms we don't want and press Delete to get rid of them. Now, there will be 4 in this case. It'll be the carbon, the nitrogen, the oxygen, and the hydrogen. So now that we've done that, we can highlight the peptide bond in a different color as per the previous tutorial by finding our peptide bond. In that case, that is here, I believe. And we can go ahead and click on the Material Properties tab. We can press the Add Material Slot button, add a new material, which I'm going to call Peptide Bond. And now that we have this in this list, go ahead and select Stick by clicking on it, and press the minus button to get rid of the material. And this isn't deleting the material for the whole molecule, that's just deleting the material for this particular bond. So now that that's done, make sure we have peptide bond selected and the right bond. Click the Use Nodes button so that it is no longer blue, and this simplifies our selection a lot. And we can go ahead and press Base Color and change it to whatever I want, or whatever we want rather. And in this case, I'm going to set the peptide bond as a nice orange color. Now note that it looks a little darker here, but it will appear a lot lighter, I believe, in the final product. So I'm going to select an orange like so, and now I'm going to export this by pressing File, Export, Export to FBX, and then I'm going to save this to my desktop and just click on Export. I'm going to close Blender. Not going to save this, and once again, as per the previous tutorial, so I guess this is just another recap, we go to AnyConv.com, we drag in our file, which I forgot to rename, convert to GLB, and hit the convert button. Once this is done, simply click Download, and navigate to your Downloads folder, like so. And we can double click on it to have a look at it. As we can see, the peptide bond is highlighted in orange, and we can now safely import this to ClassVR as per tutorial 1. Now next, I'm going to show you how to show hydrogen bonds, so let's close this down and open up Avogadro again. Once more, make sure that the tool settings and display settings boxes are highlighted, and make sure that the ball and stick and label checkboxes, in addition to the hydrogen bond checkbox now, are selected. Next, let's add some water molecules by selecting oxygen as our element, and then simply clicking where we want these water molecules to appear. And the hydrogen atoms will be automatically filled in because we have the Adjust Hydrogens box checked. Now, as you can see, any molecule that is close enough and aligned in the correct orientation will have hydrogen bonds drawn by a dotted line. Now, to actually sort of encourage these hydrogen bonds to form, we can further move around these molecules and rotate them. And the way we do this is by clicking on the selection tool, and we go down to selection mode and select molecule, and we click on the molecule we'd like to move, let's say this one, and then we go to the manipulation tool, and we can left click it to bring it closer, and we can right click it to rotate it. Now at this point I would suggest trying to remember the hotkeys, F11 for selection tool and F10 for manipulation tool, because every time you want to select and move a new molecule, you're going to have to swap between these tools. In this case, I'm going to press F11 to select the selection tool to deselect this molecule by right clicking, and left clicking to select this other molecule. Then I'm pressing F10 to go into the manipulation tool to then move this molecule around and rotate it, like so. Now just to be neat, I'm going to try and arrange all of these molecules in a way where the hydrogen bonds are as close to a plus shape as possible. Now that this is done, you'll notice that we have the hydrogen bonds showing, and when we actually import this into Blender, these won't show up. So we have two options of adding in these hydrogen bonds. One is done through Avogadro, and one is done manually through Blender. So first option, what we're going to do is simply go to the Draw tool again, and set the element to hydrogen, and simply click and drag between the atoms that show this hydrogen bond. And this will sort of create a standard bond, standard covalent bond. However, in Blender, we're just going to go and color them differently. So now that this is done, we can go ahead and save this. I'm going to call this water.pdb and save it to my desktop. And now we can go ahead and open up Blender. Now let's go ahead and import our file by getting rid of the cube, going up to File, Import PDB, navigate to the file, and then go and select the preset we created in the previous tutorial. Next, let's get rid of those duplicate atoms by going to Object, Apply, Make Instances Real, and then Object, Show Hide, Show Hidden Objects. Now we can just click on the molecules or atoms we don't want and press delete to get rid of them. Now you'll see that our H bonds have been represented like any other bond, and we can differentiate these by either A, changing the color, or B, changing the radius. So to change the color, as per the previous section of the tutorial, we go to the Material Properties section, add a new material slot, add a new material. I'm going to call this H bond. I'm going to go to Stick, remove the material slot, uncheck the Use Nodes box, and then change the color. For the purposes of this tutorial, I'm going to select a nice purple color for hydrogen bonds. And then I'm going to go ahead and apply this material to each of the other H bonds in question. Now to change the size, what we need to do is click on the bond we want to change, go over to this icon that looks like a square surrounded by a crosshair, which is the Object Properties tab, and then we can adjust both the Scale X and Scale Y properties to our new radius. Now, if we set both the X and Y scale parameters to 0.5, that's going to set the radius to half, and the Z scale factor will affect the length of this bond, which we don't want to change. So I'm just going to go ahead and do this to all of the other bonds in question, like so. And now we are ready to export. We do this again by going to File, Export, FBX, and we're going to call this HBond Test 1 for the purposes of this tutorial, and we're going to hit Export. Now the second option, going back to Avogadro, would be to add these extra bonds in Blender itself, which I am going to say right now is the more difficult option. Now although this may look quite messy, as long as you adjust the position and rotation of these molecules, you can get this same sort of diagram to look a lot neater. But using the other technique where we add the bonds in Blender, I'm just going to start by getting rid of these bonds that we added. Next, what you're going to want to do is click on this Adjust Hydrogens checkbox so that it is toggled. Go make sure you're in the Draw tool, select hydrogen, and simply click and drag and draw a pair of bonded hydrogens. And this essentially is going to give us a bond which we can then copy and paste in Blender. Now we simply export this as it is, and I've just hit save because I've already named this file previously, and this is just going to update our previous Avogadro file. Opening up Blender again, once again let's go and import the molecule, like so. And now you'll see that we have our pair of hydrogen atoms with a bond between them over here. As usual, we need to make instances real and show hidden objects before deleting the duplicate atoms. And in addition, let's get rid of these two hydrogen atoms because all we want is this bond here. Now what we're going to do is position this how we want it, and we can do this by selecting the object by clicking on it, like so, and pressing the G button on your keyboard to enter the grab tool. Now this means we can move this around with our mouse, and to move it on a single axis, we can just press that button on our keyboard, for example X, and that means we will be locked to moving it across the X axis, Y, and Z axes respectively. Now, as you can tell, this is rather difficult, and this will take a lot of practice to get used to. And as a result, I actually recommend the previous method, but this is in the event that Avogadro won't let you create a bond in between the places that you want. Now that this is in the place we want, we can adjust the scale once again by using the Object Properties tab, and we can go into Material Properties to change the material. And as I'm working from a new file, I'm going to need to create the H-bond material once again. And because that was very time consuming, I'm not going to repeat this process for the other water molecules, and I'm just going to export it right away. And this time I'm going to name this one H-bond test 2. And once again, the next step is to convert both of these files into a GLB file by simply dragging them into this AnyConv website and hitting convert. Once these have converted, simply click download and navigate to your downloads folder, where we can then preview these files that we've made. So using the first method, in which we created the bonds in Avogadro, this is the final result, showing hydrogen bonds. And the second method, in which we used Blender to add the hydrogen bonds manually, this is the result. More or less the same thing. We have tighter control, or sort of more unrestrained control of where we want the hydrogen bonds using the second method. However, it is a lot more finicky and a lot more time consuming. And that concludes this tutorial. Thanks for watching.